In this video, we're going to be going over example 11.5 from chapter 11, population distribution versus sampling distribution. So in this problem, they say if we measure the DMS odor, which is something they had talked about in a previous example, but if we measure the DMS odor thresholds of individual adults, the values follow the normal distribution with mean equals 25 micrograms per liter and standard deviation sigma equals 7 micrograms per liter. This is the population distribution of the odor threshold. So this is, for all of the adults, the mean and the standard deviation. So that's the population distribution of the actual people's values. Now, if we take many simple random samples, that's what that SRS is. And simple random samples is a very scientific process. So we're saying that we took some even though we're calling it simple random samples, we've done a formal randomization process. So we've taken a whole bunch of samples of size 10 from this population and found the sample mean for every single one of those samples. And then we've mapped out the distribution of those sample means. And the figure that we're going to show in just a moment shows the distribution of that sampling. So the distribution of all of the means of all of those samples of 10 people that we did. The sampling distribution is also normal, and we can assume that the mean is the same as the mean of the population of 25. And the standard deviation is, according to the formula, sigma divided by the square root of n, where n is the number of people in the sample. So our standard deviation for the sampling distribution is 7 divided by the square root of 10, which equals 2.2136. So as we look at the graph of these two different distributions, this is one graph that has both of the distributions on them at the same time. So we have here our population, so I have n sub p to simulate that it's a normal distribution of our population, has a mean of 25 and a standard deviation of 7. So this is our population distribution down here below. This is a distribution of all of the values, all of the individuals in that population and their individual scores in that DMS odor threshold. So you can see we have the mean here at 25, and it has a standard deviation of 7, which compared to set 25 means it's a pretty wide curve, and when it's wider, therefore, it's going to be lower. Now, on the other hand, our sampling distribution, we have here, it's again normal, and this is a sampling distribution. This is not the distribution of one sample. This is a distribution of the means of all of those samples of 10 that we took. The mean again is going to be 25, but the standard deviation is 2.2136. And you see that this distribution is much taller and narrower. That's because all of the different means of all of those different samples are much closer to the actual mean of the population than all of the individual values within that population. So the sampling distribution is always going to be narrower. The standard deviation of the sampling distribution is always going to be smaller, because by sampling all of those different groups of 10, we're getting a much more precise measure of the mean. And remember that the standard deviation is a way to measure how spread apart the population is. So wider standard deviation, larger standard deviation means a wider spread. That means that there is more variation in the values. When we're taking all these samples of 10 and adding up all of the, and looking at the distribution of all of those means, all of those means are going to be closer to the actual mean, which is where we get the smaller standard deviation.